Okay, this is a review of some vector math, and for AP Physics, I suggest that you review the sections on vectors that can be found on the website. I believe they're in Chapter 2 or Chapter 3. And so we're going to just do a short review and then see if we can go a little bit further. So a vector is a quantity that has a magnitude and a direction. So let's talk about one dimension for now. And if I let's draw a one-dimensional axis here. There we go. And I have, for example, a boat, a motorcycle, a car, or just a person walking, and they're walking in a line. So they might be walking at a particular speed, a particular rate. So they might be walking so many meters per second or so many feet per second. And so that's a quantity. Let's say you have a guy over here. Well, let's do this. I didn't do it right. So here. So let's say we have our friendly guy over here, and he's going for a walk. And let's say this is the east direction and the west direction, and let's say he's walking east. So we can show with a vector like that he's going in this direction, east, at say 3 feet per second. That's how fast he's moving. Every second he moves 3 feet, and he's moving eastward. So if you look at the vector, the length of the vector here will represent the magnitude, and the arrowhead will tell us the direction. So would you guess that if he slowed down a little bit and only walked 1.5 feet a second, his vector might look something like this? Assuming he's going in the same direction, the vector might look like 1.5 feet per second. Notice that the length of the arrow or the vector is half the length of the 3 foot per second vector, but it's still showing the same direction. Suppose he speeds up and starts to run a little bit, and he goes at 6 meters per second. Then you can imagine that he might be going like this. He's in this direction, and this is 6 feet per second. So in either of these three cases, we see that the arrows are telling us exactly the direction that he's going, and the length of the arrows are telling us the magnitude or the amount or the quantity or the strength of what we're talking about. In this case, we're talking about speed. So he's going 6 feet per second, represented by the blue vector, 3 feet per second by the yellow vector, which is half. Notice it's half the length of the blue vector. And then the smallest speed, 1.5 feet per second, is half the length of the 3 feet per second. So these are all vectors. Vectors show us a magnitude and a direction. These are the magnitudes as represented by the length of the vector. The arrowhead shows the direction. Now, in one-dimensional analysis, the vector can only go one of two ways. If you have an axis like this set up, and let's say this is my x-axis, this is what's traditional to label a horizontal axis as x. We can have either left or right. If we go right, we could say he's going east. If we could also go, he could also walk in this way. And let's say that this is 3 feet per second, heading in this direction. So that's it. For one dimension, very, very simple. Now in one dimension, you can add vectors very, very easily. As let's say our guy up here, and for right now, let me just redraw our sidewalk here. So here's our situation. And let's redraw this guy here. Oh, if forgot to do that. Here we go. Well, let's see. Sorry about this. Here he is, looking kind of ill. Let's say he's walking 3 feet per second in this direction, eastward, 3 feet per second. I'm going to just identify this vector with the magnitude. 3 feet per second, it's going to the right. And there's a strong, strong wind blowing from the west. And I'm going to make the wind in blue. And let's say this wind is blowing him here at 1 foot per second. So it's kind of helping him along. It's blowing on his back. Can we find the resultant or the total strength, or how should we say it? The total speed would be his speed, 3 feet per second, plus the wind's helping him out now. So he's actually going 4 feet per second. So what you're going to do is you're going to add two vectors. So when we want to add two vectors, we want to take this vector here and this vector here and add them together. If we're talking about one dimension and both vectors are in the same direction, then, and let's call this vector A and this vector B, and instead of putting in the feet per second, I'll just make it for generalization. Let's just say in general, this is just any old vector A, and the way you show a vector is by putting a little arrow on top. So this is vector A, and this one here is vector B. In order to add these two together, if they're going in the same direction, we simply take the magnitude of one plus the magnitude of the other, and we get a new vector, where C, the magnitude of C, sometimes we show magnitude with an absolute value sign. The magnitude of C is simply going to be the magnitude of vector A plus the magnitude of vector B. So vector A's magnitude in this case might be, let's assume this is vector A here, this is vector B. Let's say vector A would then be our 3 feet per second, and our B is 1 foot per second. So the magnitude of C is going to be 4, and that's going to be feet per second. So that's the magnitude of vector C, which is the resultant. This is called the resultant, okay, of A plus B. They simply add together. Now you might guess that if you have one vector, let's use a different color here, going in this direction, let's say this is vector A, give it a magnitude, let's say 4 meters per second, going this way, and I have another vector going in the opposite direction, and I want to know what's the end result, what's the resultant vector of this type of thing. Then let's call this vector A, call this one here vector B. Vector A plus vector B is simply going to be, if you assign that direction as positive, then you're going to have 4, and then you're going to have minus 2, because 2 is going the opposite direction. If to the right is plus, then to the left has to be minus. You're going to add these two, the 4 and the 2 together. You're going to get vector C, A plus B equals C, which is going to have a magnitude of 2, and it's going to be to the right. And that's all there is to one-dimensional vector analysis. In the next video, I'm going to introduce two-dimensional vector analysis.